Hello and welcome back. We're going to continue chapter 9 today. We're going to look at a new type of conic section, this one right here, called the hyperbola. So we're going to start section 9.2. So the hyperbola is what you get when you take like a vertical plane through a double cone. And you can see we actually create like two curves. A place that you might see it in real life is you've got a lamp with a cylindrical lampshade next to a wall. The light that is cast from that will create a hyperbola. The definition of a hyperbola, it's the set of points such that the absolute value of the difference of the distances from two distinct points or the foci is constant. So basically, no matter what point you pick on the hyperbola, so like if you pick point P, draw a line to focus 2 and to focus 1. If you find the difference between those, you'll get a number. And then you could pick any other point, like this orange point here. If you find this distance and subtract them, you will get that exact same number. Same thing for point Q. That distance minus that distance will be that same total. And then that green point there, that distance minus that distance will be the same total. So that's how a hyperbola is defined. Your hyperbola could face left and right like this. It could open up horizontally like this one, or it could open vertically like this one. And for these two different types of hyperbola, there is, an equation. So for this one, the equation looks like this, and you can see that it's very similar to the equation for an ellipse. The only difference here is that you've got a minus sign here instead of a plus sign. So you've got x minus h squared over a squared minus y minus k squared over b squared, and then it always equals 1. Now for this one, the key is that the y term comes first. So you've got y minus k squared first, and then it's still over a squared though. So the number underneath the first fraction here is always called a for a hyperbola, which is different than we call them for an ellipse. And then for this one, you've got a minus and then x minus h squared over b squared equals 1. There is a lot of vocabulary for a hyperbola, just like an ellipse. So let's take a look at what all these terms mean. The center is the midpoint of the foci, so that's the center of the hyperbola right there. The vertex, now for a hyperbola, there are only two vertices, and they are at the point on each branch that is nearest the center. So that would be these two blue points right there are the vertices. Then the transverse axis is a line segment that connects the two vertices. So this line right here, from this vertex to this vertex, is called the transverse axis. And then the conjugate axis is the segment that's perpendicular to the transverse axis. So this line right here is called the conjugate axis. And then we also have these green lines here that are asymptotes. Those are lines that this hyperbola will approach but never actually reach. So that's an asymptote, and then there's another asymptote. Okay. Then we have these values a, b, and c, just like we do for an ellipse, but they're defined pretty similarly. A is half of an axis, but a is half of the transverse axis. So that you can see right here is a. That's the distance from a center to a vertex. That's the transverse axis. B is half the conjugate axis, which would be right here. That's B. Now for a hyperbola though, A could be smaller than B, okay? Or B could be smaller than A. C is still the distance from the center to the focus, but the center or the focus is farther away from the center to than the vertex is for a hyperbola. So that's C right there. So for a hyperbola, of these three numbers, C will always be the biggest one. And there is an equation that relates these three measurements, and it is similar to what we had for an ellipse. These are two versions of the same thing. If you look it up in a book somewhere, it'll probably say b squared equals c squared minus a squared. Personally, I like remembering it this way, and that is exactly the Pythagorean theorem. And the way I remember it is that c is always the biggest. So these two squared add up to the longest thing squared. A squared plus b squared equals c squared. All right, let's take a look at how this all works. So let's write the equation for each of these hyperbola. So what I'm going to do is I'm going to start by looking at this one on the left here. First thing I should do is just look at which way it opens. Since it opens to the left and right, x will come first, and then I'll be subtracting the y term. And then I look at the center. The center is at 0, 5. So that gives me the numerators. X comes first, x minus 0 is just x, so it's x squared, and then y minus 5 squared. And then basically I don't really have to worry about which one's called A and which one's called B. All I have to do is say, okay, in the x direction, we've got 1, 2, 3, 4, 5 from the center to the vertex, so 5 squared goes underneath the x term. In the y direction, I've got 1, 2, 3 units from the center to the edge of this pink rectangle here, so 3 squared goes underneath the y term, and then it equals 1. And that's it. Alright, let's take a look at this one. This one opens up and down, so y is going to be first and x is going to be second. The center is at 2, negative 4, so that gives me this. It's y minus negative 4, y plus 4 squared, x minus 2 squared. So just make sure you've got those in the right order. And then in the x direction, you can see it's 1, 2, 3, 4, 5. So 5 squared goes under the x term. Now you'll notice I don't care whether that's called A or B. It actually is called B, but I can still get it in the right place without knowing that. And then in the y direction, 1, 2, 3, 4, 5, 6. 6 squared goes there. And there's the equation for each of those hyperbola. All right. Next, write the equation of a hyperbola with foci at 7, 1 and negative 3, 1, whose transverse axis is 8 units long, then graph the hyperbola. So I already made my graph here, but I'll show you the order I did stuff in. So the foci are at 7, 1 and negative 3, 1, so I plotted those first. The next thing I needed to do was find the center, and I did that by just going halfway between these two foci, so that's at 2, 1. The next thing I did was I drew in my transverse axis. If it's 8 units long, the center will be the midpoint of that, so I basically went 4 units on each side, and the transverse axis connects the vertices, so I knew at the end of 4 units from the center would be a vertex, and then 4 units that way would also be the vertex, and I knew it was horizontal because it needs to be lined up with the foci, which are arranged left and right of each other. And then from there, the last thing I needed to do was I needed to find this distance right there. So what I did was I used this distance and this one. So that would be, I used the fact that A is 4, and then C is 5 by counting that the center to the focus. And then I needed to find B, so I used this formula, A squared plus B squared equals C squared, to find that B squared is 9, so B is 3. And then I was able to draw this 3 units away, and then drawing this rectangle in helps you draw your asymptotes in the right place, so then you can draw your hyperbola through the vertex and within those asymptotes. So through that vertex and within those asymptotes to complete the picture. And then to write the equation, since it opens left and right, x comes first. It's centered at 2, 1, so it's x minus 2 and y minus 1. And then in the x direction, we've got 4. In the y direction, we've got 3. So beneath x goes 4 squared, beneath y goes 3 squared. And there's the equation for this hyperbola. Next thing we're going to do is talk about these asymptotes. You can see I have an equation written down right here for the asymptote. The asymptote is a line. And what we're going to do, we'll often be asked to write the equation of this line, and we're going to use point-slope form, which is y minus y1 equals m times x minus x1. So x1, y1 is a point on the line, and m is the slope. So the point on the line that we're going to use is the center, because all asymptotes will go through the center of the hyperbola. So this x1, y1, we're always going to use the center. The slope of this line, you can see, will be, well, when I draw this, it goes through the corner of this rectangle, so all I need to do is find the slope by doing this rise over this run, which happens to be the values of b and a of this hyperbola. So basically the idea here is that the asymptotes go through the corners of this rectangle created by the transverse and conjugate axes. So this rectangle here is not a part of the graph, but it's drawn in a dotted line because it helps you draw the hyperbola. So if your hyperbola faces left and right, the equation for the asymptotes will be this: y minus k equals plus or minus b over a times x minus h. So hk is the coordinates of the center, and then there are two different asymptotes through the center. One of them has a positive slope, one of them has a negative slope. That's why we've got a plus or minus here. And then the slope will be b over a. And then if your hyperbola opens up and down, it's almost the same. The only difference is it's called a over b instead of b over a, because this time the vertical distance is a and the horizontal distance is b, or it was the other way around in this one. Basically, I don't really even worry about which one's called a or b. I just always think it's rise over run. So I just look at my picture that I have to decide whether it's a over b or b over a, but it's always just rise over run. All right. So let's put that all together here in this last one. Find the coordinates of the center, foci, vertices, and the equations of the asymptotes, and graph this hyperbola. So I'm going to start with the graph here. The center's at. Pay attention to the order here. This is y, this is x, so this needs to come first. -3, -2 is right there. And then in the x direction, I go 5 units away from the center. In the y direction, I go 3 units away from the center. Because y is first, the y direction will be the one with the vertices there and there. So that's why the vertices are 3 units above and below this center. Next, to find the foci, I'm going to use this formula here. And this time a is 3 and b is 5. So I solve that to get that c is the square root of 34. And because y is first, and the foci are going to be above and below the center, not left and right, because this is going to open up and down. So from the center, I add or subtract square root of 34 to the y coordinate. And those are the coordinates of my foci. Next, the equation of the asymptotes. So the asymptotes will both go through this point right here, which is -3, -2. So I plug in those values for h and k for the x and y coordinates of that point. And then the slope, rather than paying attention or worrying about which one's called a or b, I can just look at this and say, okay, the rise is 3 and the run is 5, so it's going to be 3/5. So there's the equation of my asymptotes. The coordinates of the center, -3 goes there, so x minus -3 is x plus 3. Y minus -2 becomes y plus 2. And then it's plus or minus 3/5 right there. So that's everything there is to know about hyperbolas. So give that homework a try, and of course, email me if you have any questions.